All right.
All right, hey, listen, welcome back. We're here with the Sandoval crew, ready to do our next lesson. And with that, we have Marcus, Max, and Celeste with us today. Same thing again. Okay, now let me go ahead and share my screen with you. Now, the new thing that we're going to learn about today is actually about something called segment addition postulate. And so with that, let me go ahead and go to the next screen. And Celeste, why don't you read this? Oh, Celeste, you're on mute.
Basic terms. Two segments are congruent. Segments, if they have the same length. In the diagram, PQ equals sin RS. So you can write PQ equals sin RS.
No,
this is studied as segment.
Well, hold on. Let me stop you there, Celeste. You see the symbol right here? Okay, you know why I stopped you and why I said that's important? Is that because this is that's symbol for congruency. Okay, so keep on reading now.
This is read as segment. PQ is congruent to segment RS.
Yeah, good. Keep on reading.
Okay. Tick marks are used in a figure to show congruent segments.
Yeah, so the tick marks are these. You see these right here? They call these tick marks. Now, Marcus, let me ask you a question. Why do they call it congruent?
Because they're not exactly the same.
No, they are the same. But why not use equal? Are shapes numbers?
No?
No, right? So technically they're the same in idea, but they're not the same as far as their, they're not like a numerical the same. Does it make sense? Like equals means they're the same, while congruency means the same, but just in shapes. So that's the difference. Okay, good. All right, so now Max, read this one.
Basic terms, equal versus congruent. Numbers are equal, figures are congruent.
Yeah, so that goes to show you what you said before, right? Now, Celeste, read this next one. Celeste, you're on mute. Celeste, you're on mute.
A ruler can be used to measure the distance between 2 points. A point corresponds to one and only one number on a ruler. The coordinate of a point is the real number that corresponds to a point.
All right, good. Okay. So Marcus, what is this saying then?
I don't a place, I guess.
Yeah, I guess they're saying that if anything, you're always guaranteed a certain measurement and you're never going to be false, depending on where you start from, though.
Mm-hmm.
Okay, Marcus, read this one.
Find the length of a TV. So show your work below and put the answer in the yellow box.
Okay, good. Now, I think they missed something. What did they miss, kids, here? That if I had to correct about what they did, then they didn't do.
They forgot to put a little point or line, above them.
The low line, right? Yes, good. Okay, so Marcus, what is the length of TV?
It should be 6.
Yeah, -8. Great. All right, Max, read this next slide. Oh, no, it shows you right there. 14 minutes. Hey, now something new though here. Take a look. What do you notice? Celeste, stop. Make sure you keep yourself unmuted.
Okay.
Okay.
I'm just used to because in our classes.
No, don't worry. Yeah, no, just keep yourself unmuted. You're doing a Sandoval class. All right, now, Max, why do they put absolute values? What are they for?
Wait, where's absolute values?
These are absolute values right here.
The lines?
Yeah, the lines. These are called absolute values. Why do they put absolute values?
Why do they put absolute?
Well, what does an absolute value do?
I don't remember.
Okay, here, Marcus, you remember what an absolute value does?
It just makes the number positive.
Yeah, so like in this case, this little bracket. Now, why would we want to make a number always positive?
Because you can't have negative distance.
Yeah, that's exactly right. Is it possible for me to run negative miles?
Nope.
No. I always ran some kind of miles, right? Now, I maybe ran in the wrong direction, but it doesn't take away that I ran. So that's the reason why that's so important, or why we'll use that in real life. All right, good. Okay, now, Celeste, go ahead and read this next one.
Find the length of ST. Show your work below and put the answer in the yellow box.
Okay, Celeste, so lead me through. What would I do? Let's see. Marcus, why don't you help her out? What does Celeste have to do to find ST?
ST.
Yeah.
She would have to subtract -4 from 8.
Yeah, 8 minus -4. And here's an important concept. What happens here?
The -4 becomes a positive or something pluses.
Yeah, it does, right? Yeah. Now, just to look at this part, because I know some people are sometimes wondering, well, why does that really happen? Well, this means opposite, right? Correct? You all agree? So what's the opposite of -4?
4.
Positive?
Yeah, so that's the reason why this becomes positive. That's the exact reason why. So when you see a negative, it's saying the opposite of -4 is +4, which this results in 12 as a result.
Sorry, Daddy. It's just that I haven't been taught negatives.
Oh,
yet.
no worry. Now that's one benefit you're going to have. Now you know this. Now let's see this next one. And here it is. It shows you right here. They use absolute values again because you can't go negative distance. Okay. So now, Marcus, read this segment addition postulate.
If 3 points A, B, and C are collinear and B is between A and C, then AB plus BC equals AC.
Okay, good. So in what would be the best way for you to explain this?
If you got 2 parts of a line and added them, it makes one big line.
One big line. There you go. I love that. Actually, I love the way you explained it. Yeah. This plus this makes the big line. Very good. Okay. Now let's go ahead and Max read this next one.
Find the length of AC. Show work below and put the answers in the yellow box.
Okay, so tell me, what do I do?
You add both of them.
Good. And then AC becomes what? That should be 3 plus 7 is 10. 0.2 plus 0.9.
12.2. 12.1
Or 11.
or
11.1.
11.1.
Yeah, 11.1. Good. All right. So let's do this next one. And there shows you right here too. All right, so let's do this one.
Find the length of BC. Okay, so we see that A and B have 60 and 43, so you do 43 minus 16 to get your B and C.
Ooh, love it. Now tell me what is the result of this? Hold on. Let's go.
The result is 7.
Yeah, so the solution is 27. And you can find it because if you add them together, you get 43. Okay, Marcus, go ahead and it shows you right here too. It shows you more algebraically. That's one thing it does do. All right, but Marcus, go ahead and now read this one.
Show your work below and put the answer in the yellow box.
Okay.
So we got 502 being the big line. We want to figure out AB, and 337 is the other line.
Yeah,
So
so what do you
552 minus 377 would be 35? No,
Yes.
135.
135. Yeah, 135. So if this was 135, then these two lines will make the 502. Very good. All right, next is the next one. Well, here, hold on. So kids, what would you say? Thumbs up or thumbs down, segment addition postulate?
Great.
Thumb up, good, cool. All right, so we're here. Okay, now, what about this one?
Well, it would be, what is that? 11x plus 21.
Yeah, good. You did more, I know, but do you see these answer choices right here?
Oh, yeah.
Which is the right one?
Let me think.
Um,
Okay, my guess it could be D.
You think it's D?
what does the X mean?
X means that it's a value that we don't know what it is. So we just put a placeholder.
Hmm.
Oh, it'd be C.
It would be C.
Let's see.
Absolutely right. Yeah. Why? Okay, now let's go back because I
But
know
that,
some
you
of
didn't read
you.
the question, did you?
Yeah. Now in this case, remember if these were just numbers, like let's say this was 10.
Wait, no, Dad, you didn't read the question out. There's text above it, and you forgot to say it.
Oh, you're right. Okay, but everybody knows it's C, right?
Yeah, but you don't
Right
know
here.
why.
Well, let's explain. Oh, you know what? I used green already. Let me take away the green. Okay. And we know it's C, right? We're showing
Mhm.
it. Okay, so this green part, it's that part. The red part, see if I can use red. That part is this part. And they were saying that the whole segment equal to 120, so this is this part here. Now, it's the same thing if I would have told you, okay, this is, oops, hold on. If I would remember, these are eventually just numbers. So as a result, if I would have said, okay, this is 40 and this is 80, you would tell me, well, then the whole thing will equal 120. That's the same thing here. It's like saying, okay, this is 40. The result of that is 40. And this over here is 80. And you would tell me, oh, the solution is 120. Does it make sense? There's an X value that will make something that will make this work. And what it is, we have to do more math to get it. But at least it gives you the concept of the introduction. Okay. Now let's go ahead and go to the next one. And so here, oh, they're actually doing some things for us. Let's see. So it goes to show you the whole thing's 120. And then they go ahead and show your work. So, oh, so let's actually solve it though. Okay, so with this, any of you kids, what do I do first? Actually, I think Marcus, you said it. What did you tell
Gotta
me?
simplify.
Yeah, we gotta simplify. So what do? Lead me through it.
Minus
So
4. Oh,
Yeah, so what do I do first?
you get the family members together. You get
Yes.
4x plus 7x with 6 plus 15.
So we get 11x, right? Now notice how I'm tagging them. Notice how I tag them? I tag them to kind of know that these two go together. So like the 6 and the 15, that's 21. And that equals 120. So walk me through. What do I do next to solve for x?
You would divide by 11.
No.
you
First,
subtract. You
all right,
subtract.
hey kids, well, hey, how many of
Yes,
you kids know PIMDAS?
Yes, I know.
Love it. Okay,
Tell
I'm
me
glad.
this.
That means that they're doing a good job. Now, if you know PIMDAS, when you solve, notice how it's all the way simplified, right? All simplified. Can I simplify any more? Yes or no? No, I can't simplify anymore. When it's all the way simplified and you have to solve, you have to do PIMDAS backwards. Okay? So you go backwards. So this is so you do everything, this is our step, like imagine going 1 and going this way, right? So notice how the first thing I gotta do is take care of addition and subtraction.
Yes.
Okay, so if I do addition and subtraction, what's the first thing I gotta do here? I'm doing everything backwards.
Yes.
You would subtract 21.
Yeah. As a result, I would get 99. So notice how I cancel addition, subtraction, it's all gone.
Yeah.
So I move on to step 2. Multiplication, division, right? I'm doing everything backwards, right? So then what I do here. And if this thing was more complicated, x would be 9 as a solution. But if things got more complicated, once you're done with this, then you would be solving for exponents and parentheses last. But we don't have any of these. Otherwise, I'll make your mind blow up. Right? If I did.
The thing is, it's not asking for x. It's asking for us to find JK and KL. So we got to substitute.
Oh, yes. So once we have x, you're right. You're absolutely right, Marcus. So then once we have x, what do I do next?
You have to substitute.
Yeah.
So it'd be 4
Oh.
times 9 plus 6 plus 7 times 9 plus 15. Actually, no. Wait.
Yeah, good. So this is
You
going to
don't have to add
be
the two together, actually.
what was that?
You don't have to add the two together. You just have to find them out separately.
No, you could. Well, that's true. But eventually we're going to add them together, right? Oh,
Yeah.
yeah, but you're right. They do want them. They do want them separately. So let's see. Oh, I can't move it. Well, I'm going to erase one of them. Well, not erase one of them, but erase part of it. Okay, so this is JK. All right. So then that means JK was 42. And then KL was 7 times 9 plus 15. So then what is that? That was
48.
that's 63, right? 63 plus 15 comes out being 78. You all my math right?
Yeah.
78. Good. All right. So then there's our two values. All right. Now let's all right. So oh, and it shows you here. So we were correct. Notice these two. 42 and 78. So we did it right and we solved correctly too. All right. Now let's go ahead and do the next one. And Max, why don't you go ahead and read this one?
Circle the correct equation to use to find length of segment no.
Okay, good. So segment no. So which is so open question to everybody. Which is the correct one? You know what? I think they made a mistake.
The second one.
That's it.
Yeah, the second one. Yeah, I think that's good.
Or maybe they didn't make a mistake. You're right. Okay. Why did you not pick this one?
Which one?
This one.
Because that's minus
Good. This is correct.
the whole line.
Yeah, because remember 17 plus 3x minus 5 is going to equal the whole thing. All right, good. Now let's go ahead and move on to, yeah, and it shows you there.
Oh, that's all.
Okay, good. Now, in this case, well, actually, this would be more of anybody here. What's my first step in solving this?
I've solved it, Dad.
You solved it already? Very good. But what's my first step?
3x minus 5x.
No.
You get the families together.
Yeah, you start simplifying, right? So it's 17
Okay,
to the 5.
17
So
minus
on,
5.
and now remember, keep in mind, the equals is division. Like you got to do it from either side. You can't like intermix in this case. It's like a balance. You got certain things weighed on this left side. So like in this case, this is then going to be 3x plus 12 equals 5x plus 2. All right, good. All right, so then what's the next thing I do?
Well,
3x minus 5x.
Now, you said 3x minus 5x, right, Max? Now, you notice how there's two x's? Our ultimate goal is to get all numbers on one side, to get x's on one side, and all numbers on the other side, right? This is my ultimate goal.
Oh,
Okay, now,
minus. Okay,
no,
minus.
no, wait a second. No, wait. These are interchangeable. Just hold on. These are interchangeable. You can have numbers on one side. It doesn't matter what side the x is on. But you got to make sure you keep it just on one side. Can't have numbers and x's together, right? Okay.
Yeah.
So this is important though. Do you like working with negative or positive numbers?
Positive.
Okay, good. I do too. So because of that, the first thing you need to do is look at the equation and pick out the smaller x. When you have a multi-step like this, so you notice how the smaller x is 3x? Subtract this one first. And as a result, not always, but many times you're gonna end up with the positive x. All is equal to 2x plus 2. Notice that?
Yeah.
And then we start putting numbers on the other side. Notice how I have 2 here. So remember using PIMDAS backwards. Subtract 2 to both sides. 10 equals 2x. So as a result, divide by 2, divide by 2. X is equal to 5. Now remember, they want to find the length of segment NO. So that, since I have the 5, then the only thing I need to do is NO is equal to 5 times 5 plus 2. So I can guarantee you then that my solution is going to be 27. Okay. Now let's go ahead and move on to the next one. Well, the next one's probably showing the work too. See how they did?
Daddy,
Yeah.
what does NO mean?
Oh, that's a
That's the
segment.
of the
Yeah, that
line.
was the segment right here, the line. So you see this line right here, NO, and I'm glad you brought it up. So they were basically looking for, I use this equation since that whole equation represents the whole line. And since I had found out my x is 5, just like they did here, and this is how I went ahead and substituted in, and then this, I could go ahead and prove to you that I have 27 as a length.
Okay, thank you.
Yeah. If this was, if you put 5 in here, this thing comes out being 10, and 10 plus 17 is 27 as well. Okay, so it works out. Now let's go ahead and move on to the next one. So, and then tell me, kids, so what do you feel so far about segment addition, Ashley?
Happy
I
face.
feel the one that's next to the happy face.
I see. So either happy or in here, right? So where your kids are at. All right.
Mhm.
Now, the good thing about if you're in here, or even if you're anywhere over here, okay, it's all right. I get you. Sometimes some people don't get it the first time. And if that's the case, one of the benefits you're going to have is that this video is recorded. You go back and replay it, but do it with writing it down. And then pause it and see if you can do it on your own. If you do it on your own, then you're proving to yourself you're able to do it. Now, if you can't, sometimes you got to go back and just keep on trying until it all makes sense. So that's what you got to do with some of this stuff. You got to test yourself to make sure you make sense out of it. All right, good. Let's go ahead and do the next one. Solve an equation, same thing. You got to apply the same exact thing. All right, good. Now, Marcus, read this slide.
A segment bisector is a point, a line, a ray, or another segment that intersects a segment at its midpoint or bisects it.
Yeah. So in short terms, how would you describe it?
Intersecting lines.
Yeah. Well, there's 4 different ways to find the middle, right? In this
The
case,
median lines.
yeah. Well, kind of in this case, this is a point. Array. Notice how that's array.
Mhm.
Same thing. It's finding the middle, and write down middle. So here's one way to find the middle, a point. Second way to find the middle, array. Third way to find the middle, well, not find it, but you're cutting it, basically. That's what this word bisects means. You're cutting it in half. Line could cut it in half, or fourth way, a segment could cut it in half. Either of these 4 ways guarantees you bisect. Make sense? All right. Now let's go ahead and move on to this. And Max, read this key concept.
Midpoint formula on a number line. The coordinate of the midpoint is the average of mean of the coordinate of the endpoint.
All right, good. So how do you read the formula?
Formally, coordinate of the midpoint M of AB line is A plus B line 2, or fraction.
Yeah, divided by 2. So basically add them together and then divide by 2. Very easy, right? Okay, good. So Marcus, help me find the midpoint of this one.
So you got -4 and 9. So you do 9 minus -4, right? Or 9 plus -4.
9 plus, because you always add them together. Then you divide by 2.
Divided by 2.
So whenever it's a negative, you always add it?
Well, you know what? You add them together. Yes, because see, the thing is that in this case, we're going to find the middle. We're not finding the length of it. We're trying to find the middle. So the middle, according to this equation, is going to be this, and then we'll put it on the graph to see if it makes sense to you. The middle is going to be 5 divided by 2, which means the middle is 2.5. Make a mark at 2.5 about here. Say the middle is about there. That look about right?
Mm-hmm.
Yeah, it does, right? Yeah, so that's basically the way you do it. So midpoint, you add them together, divide by 2, like what we did here. And I'm imagining that that's what this slide's going to say. Oh, well, I actually didn't. Let's go ahead and figure this out. Okay. Celeste, why don't you read this slide?
Process of elimination. Crafts out the incorrect equations to set up this problem.
Okay, so Marcus, why don't you keep on, how about your sister? Keep on reading on.
Okay. If D is the midpoint of segment EF, find the length of ED and DF.
Okay.
No, we already did this.
Yes, which one? But which? Yeah. So which ones will I eliminate? Like which one's right?
Right.
Now
Okay,
you see
so-
where it says remember. This thing.
Okay,
about,
it would be the bottom left one.
it is absolutely correct. See how I'm putting these tick marks?
Mhm.
That means that they're equal, which expresses this one right here. That this
Yeah.
side is basically equal to that one. Now, why do I have the power to change it to equal? Because now we're talking about numbers.
Oh yeah.
Yeah, I could go ahead and write down ED is congruent to DF. And write down that ED numerically is really 4x plus 6, which is equal now to 7x minus 9 because I switched over the numbers. And they mean the same thing. Congruency and equal is pretty much the same idea as that, done different. All right, good. Okay, now let's go ahead and move over to the next one. Okay, so they show they blocked off, so they agree with me. All right, now let's go ahead and solve this. All right, so what do I do first?
You get all the numbers on one side.
Yeah, all the numbers on one side and all x's on one side, right? So when you see x's on both sides, always start by subtracting the smaller x. Let me pen turned off.
So +9 was 6.
You may not believe this. One thing that my pen does for me every 30 minutes, it turns off, reminds me that we've gone 30 minutes actually. All right, now here, now this is when we start working PIMDOS backwards. So we add 9, add 9. Get the result that 3x is really equal to 15, and then our solution is going to be x equals 5. Now they want us to find each length. Oops. Make that 5 a little sloppy. Okay. Now they want us to find each length. So we're going to go ahead and I'll put it here. So you can see 4 times 5 plus 6. So this is going to be 26, right? And it should be equal because we said these are equal. Let's see, 7 times 5 minus 9. This is 35, and that equals 26 as well. So notice that? So that means we did find the correct x because we were guaranteed that they had to be equal, which they are.
Congruent.
All right, now, Celeste, oh, and it shows you here. Same thing, all the steps. So if you're doing this at home, you go ahead and pause the slide and you go also do it there, or mine's the slide we did together. Okay. Now let's have, Marcus, why don't you go ahead and read this one?
Choose the correct equation for this problem. If D, the midpoint of AC and AD, equals 17, and AC equals 10x plus 4, find the value of x and then find the length of AC.
Okay, so let's go ahead and do some marking. I think that will help us. Basically, they're saying that this whole thing is 10x plus 4, right?
Hmm?
And it says if D is the midpoint of AC and AD, and it equals 17.
AC, which one's that? Okay.
Okay, so they're basically saying that AC equals 17 and AD equals 7. I'm sorry, AD equals 7.
Yeah, so it would be C, right?
Yeah, you're right. It would be C. Good. So 17 plus 17 equals 10x plus 4, the whole length of it. So we go back to semi addition and some of that. Okay, now let's do the next one. Oh yeah, and they agree with us. So that means that we did good. Now let's go ahead and do the next one. All right, now let's actually solve this one. Okay, so lead me through. Any of the three kids, they'll be question. What would I do first? Combine these two, right?
Yeah.
Then I go ahead and start doing PIMDOS backwards. So that's the reason why I deal with the 4 first. Doesn't multiply, addition. 30 is equal to 10x. And then I divide by 10 to both sides. And I get a result that x is equal to 3. And this says, okay, find x and AC. So they wanted AC. So AC, actually AC is just 34, but we'll use their equation. Because remember how they said it was 17 and 17? So we knew it was 34 already. But we're going to use the equation just to prove it. 10 times 3 plus 4. 30 plus 4. 34. No surprise. It's all there. Okay, good. Now let's go ahead and do the next one. All right, so, and it shows you here too. So here in this slide, it shows you all the work. Now let's do, all right, good. Hey, listen, we're pretty much to the end of the lesson now. Anybody want to share anything that they learned about today?
I learned congruent segments.
Oh, cool, congruency. Anything else you want to share?
I learned about the x and how the equations we had done.
Okay, no, that sounds good. All right, hey, I thank you so much for being here. Okay, thank you kids for helping me out. And we'll everybody say bye.
Bye.
Bye.